Hi everyone, I am Om Maheshwari and today we will discuss some questions on analog electronic circuits EE74 NPTEL course, and these questions will help you with the week 1 assignment. So let us start. So the first question is we have this circuit, and in this circuit our aim is to find the current ID through iterative method, right? So let us try to solve it. So here we have been given V0 equal to 2.02 volt, R equal to 0.9 kilo ohm, and Vd is given approximated to be 0.65 volts, right? Yeah. Yeah. And one more thing, Is is given to be 2.4 into 10 to the minus 16. Okay. So, so the first task is to calculate the current through the resistor R. That is, IR equals to VO minus VD by R equal to 2.02 minus 0.9, I'm sorry, 0.65 by 0.9. IR will be 1.5222 milliamperes. Okay, so this IR is flowing here, right? And it is same as the current ID. So ID will be approximately equal to IR 0.522 milliampere. Okay, so now we know for the diode ID equal to Is power Vd by Vt, right? The ideal diode equation. So if we want to get Vd will be Vt ln Id by Is, right? If we just rearrange this equation and take the logarithm. So to calculate the Vd now, so Vd will be, Vt is given to be 26 millivolts ln ID we calculated 1.5222 divided Is was 2 into 10 minus 16. So this will give us Vd to be 943.29 millivolts. Okay. So now we have got a new Vd. We started with Vd equal to 0.65, but now we have a different Vd. So we will again calculate IR. So IR now will be 2.02 minus 0.943 by 0.9. So this will give us IR equal to 1.1963 milliampere. Now if we will calculate Vd again, Vd equal to Vt ln Id by Is. So this will give us Vd to be 0.93977 volts. Now for this Vd, if we calculate IR again, it will be 2.02 minus 0.939 by the 0.9, we will get 1.2 milliampere, and this is the final answer, right? So the answer is 1.2 milliampere. So in this way, we solve this iteratively. So we will go to the next question. So The next question says, in the circuit given below, V0 is 2.02 volts, value of resistor R is zero point 0.9 kilo ohms, and cutting voltage assumed to be 0.65. You have to find the current ID. It is similar to first question, but it is not asked to take any iterative approach. So we will directly solve it. So V naught equal to 2.02. This is 0.9 kilo ohms. So if we apply KCL, right? So the drop across resistor will be, if this is 0.65 VD, so drop across resistor will be VR equal to V naught minus VD equals to 2.02 minus 0.65, 1.37 volts. Now IR equal to VR by R, 1.37 by 0.9 kilo ohm equals to 1.522 milliamperes. This is the answer. Alright, so we'll go to the next question. So in this question, we have given this diode has cutting voltage of 0.7 volts, Vx is 7 volts, R1 and R2 are 0.1 K and 2.1 K. So what they are asking is current through R2. So okay, so for this we do not know if this diode is on or off. So first we will just assume the diode to be on. So let us assume diode is on. So if the diode is on, we will from KCL, let us apply KCL, right? So we will take current okay. So if this is, let's say, ID, right? And this is let's do it in an easier 8.7 here. Okay. So now what we will do, okay. So we will just simply apply KVL, right? So if we apply KCL here, okay. So what we will get equation will be Vx minus 0.7 by R2. So is this current? Let's say it is I2 plus, let us say this current is I1. I1 will be plus I1 equal to ID. If this is ID, right? Plus I1 will be 0.7 by R1 will be equal to ID. So if we try to solve it, 7 minus 0.7 by R2 is 2.1 kilo ohm plus 0.7 by 0.1 kilo ohm ID. So this will give ID equal to minus 4. and -4 milliampere. But since the diode is assumed to be on, it cannot have a negative current, right? So that means that our assumption is wrong. This is wrong. Diode is off. So now when the diode is off, so there is no, this path is not there. So that means, so Vx, so the voltage across R2, we will calculate the voltage across R2, and for that, okay, that we do not, so we need to calculate the current across R2. So for current through R2, this is this simple path. Let me erase the extra things. So this simple path will be for the current through R2, and this path is off. So when diode is off, the current through R2 will be IR2. So the current through R2 will be the current through R1. So it will simply be Vx by R1 plus R2. 7 by 0.1 plus 2.1 K. This current will get as 3.18 milliamperes. So this will be the correct answer. So this is all for today's discussion, and if you have any queries, please reach out to me on my email ID that I have shown here. Thank you.